I am Anil Kumar sharing with you multiple choice questions based on trigonometric identities. Now questions very similar to this will be seen in IIT JEE and many AP level test papers on mathematics and even SAT. The question here is, if sine A equals to m sine B and cos A is n cos B, then tan square A is equal to what? Four choices are given to us. Now to solve this, we will need few identities, so let me share those with you. One is, 1 plus tan square A will be secant square A, correct? Secant square A. Now you could write tan in terms of sine, basically. You can say sine A is basically equal to tan is sine over cos, correct? So we can say tan A. Sine over cos. So if I divide this by secant A, we get sine A, correct? This is kind of, treat this as sine A over cos A divided by 1 over cos A. So with that, you could actually easily figure out what tan square A should be when you are given sine and cosine. So let us see how to solve such questions. We have 4 or 5 of similar kind. You should go through this playlist and understand the techniques. We are given sine A and cos A. So if I divide sine A by cos A, I get tan A, correct? Sine A is m times sine B. And cos A is n times cos B. So that gives you what tan A is in terms of m and n and tan B, right? So we could also write this as tan A over m equals to tan B over n, and this is equals to a constant. Now this is a very important concept. This is equal to a constant. We want to find what tan square A is, so what we write here is that tan A is m times constant. Is it okay? So that is one of the very critical steps in solution of such questions. Now we'll use this identity and then try to figure out what k is. So now sine A is equals to m times sine B, and we'll use this to write sine in terms of tan. So we could write this as tan A over square root of 1 plus tan square A. That is secant A, correct? So that is tan A over secant A. You get the concept. And m times tan B over square root of 1 plus tan square B. Now what we know here is that tan A is mk and tan B is nk. I didn't write here. Let me rewrite. Let me write, because we were more interested in tan A, but B is n times k, correct? So now we can write these terms in terms of the numbers m, n, and k, correct? So I'll rewrite this. Tan A is mk, so I'll write mk here, over square root of 1 plus m square k square. And m times tan B is nk over square root of 1 plus n square k square. Perfect. We can simplify this a bit, cancelling m and k. So it's kind of 1 here now after you cancel. And then we'll cross multiply. So I could write this as square root of 1 plus n square k square equals to n times square root of 1 plus m square k square. Now let us square both sides. We get 1 plus n square k square equals to n square times 1 plus m square k square. The idea is to find the value of k, so we'll isolate k. So we can write this as bringing n square to this side, we have 1 minus n square. Of course, okay, let me continue one more step. Let me open the bracket and then bring it, okay? So n square plus n square, m square, k square. Perfect. Now we'll bring n square to the left. 1 minus n square equals 2. And we have n square, m square, k square minus n square, k square. So we have 1 minus n square equals 2. N square, k square is common, correct? And we can write m square minus 1. And from here we can write what k is. So dividing, we get 1 minus n square over n square times m square minus 1 is basically k square. Now we want to know what tan square is. We know tan A is mk, so tan square A will be m square k square, correct? M square k square. Since k square is all this, we can now write this as m square, and instead of k square, I'll write this as 1 minus n square divided by, we have n square times m square minus 1, correct? So that's what we get for this particular question. Now, to match this up, we could take minus minus and rearrange this, right? Because this option is exactly same. However, it's like written in the negative form. So if I factor out negative, I get m square over n square times n square minus 1 divided by 1 minus m square, correct? So now it matches perfectly. Do you see that? So I just took negative, factored it out, and we got our result. So in this type of questions, what we are trying to do is we're trying to write down what we need to find in terms of n, m, and some other constant. And to get the equation of a constant, we use this kind of strategy. I'm going to apply this strategy in a couple of questions so that you get at least one good question right, and that will make huge difference in any competitive exam. Feel free to share your views and suggestions. If you like and subscribe my videos, that'll be great. Thank you and all the best.